So today we will see how to do the analog part. First thing is you need to log in using the user. You have to log out of digital, log in using analog or VLSI analog, and the password will also be the same. Then right click and click on open terminal. So here also you need to make directory, change directory. I'll give the directory name as 1234 for my convenience. Then click on change directory, and you need to give the command called virtuoso space ampersand and click on enter. So virtuoso is a platform which will allow you to do the digital design, and other platforms are also there like Incisive and Encounter, but for this for your lab purpose you need virtuoso. And once you click on this virtuoso ampersand, a new window called cds.log window or virtuoso window will open. From here you need to continue. So first thing is you need to create a library which is only once. Then from next onwards you can create different cell views and continue doing it. So click on file, new, library. Select attach to an existing technology library. Give library name of your choice. So I'll simply give it as 1234. Then click on OK. Then select GPDK 180. GPDK means Generic Process Design Kit, and 180 is the nanometer technology which we are using. 90 is another technology, 45 is also another technology, but we are concerned with only 180 nanometer technology. Then click on OK. Right. So you're done with the creation of the library, and the message in your CDS window will be displayed: library 1234 successfully attached to technology library GPDK 180. Next is creation of your cell views. So go to file, new, cell view. So give the cell name with the experiment which you are doing. For example, if you're doing inverter, better to give the name as inverter or INV, and it has to be under your library. So 1234 is a library which I created, so it should be under that, and by default you get the view as schematic and type also as schematic. Then click on OK. A new schematic window will open like this. So where there are so many dots, you can place the components on these dots and continue doing it. So firstly, if you want an inverter, you need a PMOS and an NMOS, and you need to give the pin connections and connect them using wires. For that, first go to create instance and click on browse. Different libraries will open. So first you need to select GPDK 180 library, which will contain components like your NMOS, PMOS and all. First click on NMOS, and symbol will be selected. Don't do anything, just close this, and it will ask for some parameters like this. Don't change any parameters for your NMOS, just click on hide. Symbol like this will come. Place this NMOS symbol wherever you want conveniently, right? And one more, if you want to place another NMOS, you can place it, but I don't want it. I'll click on escape key, it will go. Again, I'll go to create instance, browse, and I need PMOS this time. I'll click on PMOS and close this. But for the parameters, give the finger width as WP, right? And click on hide. This is the only change you will make it for PMOS, and place this PMOS symbol exactly on top of your NMOS like this, and I'll press escape. So now you can see that length and width for NMOS is mentioned like this, and for PMOS WP has been displayed. Next thing is we need to make the pin placement. Go to create pin, or there is also a shortcut called P. So the pins which we need as the input pins are V in, space VDD space GND. You can give it individually also, but it's better to type V in VDD and GND. So it will come in the order which you will give it. Then click on hide. So first is V in pin will come. Place this V in at the left. Then VDD will come. You need to rotate by pressing R on your keyboard and place it on top of the PMOS like this. Next pin is ground. Rotate it and place it at the bottom of NMOS like this. So these are the input pins. Then I'll go to create pin again. This time we need it for output pin. So direction will be output and name I have to give it as V out. Click on hide and place this V out pin at the right side. So now we are done with the pin placement. I'll press escape key. Now you need to do the wire connection. So go to create and click on wire narrow. Complete the connections. Complete the connections like this. Gate to gate connection from V in to this part and from output to drain connection. So the circuit is not complete yet. It becomes complete only when you connect the substrate to the source, right? Take the substrate and connect it to the source like this. Similarly in your NMOS also, connect the source along with the substrate and then you click on check and save on top. So if you click on the check and save and if you open the Virtuoso window, it will be displayed that this inverter schematic saved with no errors. So now we are done with the creation of the symbol, schematic. Next step is you need to create a symbol for this and followed by the test circuit. For creation of symbol, go to create cell view from cell view. So your library name will come by default, then click on OK. Now the thing is pins which are important, right? The top pin should be VDD. Bottom pin should be ground. Left pin should be V in and right pin should be V out. Click on OK. Now you get a symbol like this. Double click on this symbol and type INV or inverter and click on check and save. So two ways are there to create a symbol. One thing is you can just keep this symbol and if you click on check and save, at the CDS window it will show that this inverter symbol saved with no errors, or you can make it look like an inverter symbol by deleting these lines and adding a triangle along with the bubble. I'll do that also and I'll show. So click on this delete symbol and I'll delete this box. Then I'll use this line to create a triangle symbol like this. And I'll use this icon to place the bubble like this. Then I will just move this bubble. Then I'll complete the line connection to the symbol so that the system will understand that. So it will understand only when I click on check and save. So at the bottom it will display again inverter symbol saved with no errors. So it will understand this is the inverter symbol. So you can either keep this symbol or the earlier symbol, no issues, and you can continue. So now you are done with the creation of symbol as well as the creation of the schematic. Next thing is you need to do the test circuit. So for the test circuit, from the CDS window, go to File, New, Cell View. Give the cell name as inverter underscore test and click on OK. Now a new schematic window will open where you need to do the test circuit, right? So you need to place a symbol which you have created. For that, go to create instance, browse. go to your library which you have created. So 1234 is the library which we have created, and click on this inverter, and symbol will come by default. The symbol will be displayed at the bottom here. Just click on close, click on hide, and place the symbol somewhere at the center like this. So your symbol will be placed, either this symbol or the previous symbol which you have used. So now we need to give the parameters. For that, again go to create instance, browse. This time we need to select the library called analog lib. This will show the parameters which are needed for making the test circuit. So first thing is, for the input we need vpulse. Either you can search for vpulse or you can type searching vpulse. Click on this vpulse and close it. Some parameters you're supposed to give it for vpulse. Mainly for voltage 2 you can give it as 1.8. Don't give volts, just give 1.8 and click it somewhere here. It will take the volts by itself. Period you're supposed to give it as 20 nano, and pulse width should be half of that, which is 10 nano. Give rise time and fall time as 1 nano each, and click on hide. So this symbol will come. I'll place it somewhere near the V in like this. It will show the parameters also. Just in case if you forget to give the parameters, what you can do is click on this, right click and go to properties, and give the values whichever is missing, and click on apply and OK. Similarly it will come. Next is for VDD. For VDD we need to give the parameter as VDC. I'll go to create instance and browse. From the same library I'll search for VDC. So VDC will come. Close this. Give the DC voltage as 1.8 and click on hide. This VDC will come. I'll rotate it and I'll place it somewhere on the top near VDD like this. One more thing you need to keep in your mind is, so you have a selection box covering the symbol. Whatever the components you place, it should be outside the selection box. It should not even merge with the selection box. That thing you need to keep it in your mind. And for the Vout we need a capacitance. So again I'll go to create browse. I'll search for capacitance and close this again. Give the capacitance value as 0.1 pico and place it somewhere near the output like this. And lastly we need the ground. Create instance and browse. Here also you can search for the ground because it's of the same library. Type GND. Ground symbol will come like this, or you can search from create instance browse also. So one ground I'll place it near the actual ground, and other grounds with respect to the minus of the parameters, right? So one with the vpulse, one with the capacitance, and one with your VDC, right? So all the minus terminals should be connected to the ground terminal. Now let me complete the connection. Go to create wire narrow. Complete the connections like this. VDD to the VDC and the negative terminal being connected to the ground. Ground to the actual analog ground. Vout to the capacitance with the value of 0.1 picofarad or 100 femtofarads. Then you need to name the input and the output line. For that, click on the input line, right click, go to add name, and you can give the name as VI or VIN. If you click on this hide, you'll get that symbol whatever you have typed. Place it exactly on the line like this. Again, then you can press escape. Click on the output line, right click, go to add name, type Vout, hide it and place it exactly on the line like this. Now your test circuit is complete. Click on check and save. So once you click on check and save, at the bottom you can see the message inverter test schematic saved with no errors. So now you are done with all the three rings, that is your schematic, symbol and the test circuit. Now you need to do the analysis, namely transient, DC and AC analysis for the test circuit. But for the inverter circuit, you are supposed to do only transient analysis and DC analysis. AC analysis you can do for rest of the experiments. For that you can go to launch, click on ADEL. ADEL window will come like this. So first you go to model libraries, set up model libraries, and you need to unselect 45 nanometer and 90 nanometer because you're doing with respect to 180 nanometer, and click on OK. Next is go to analysis, choose. So under transient analysis, give the stop time as 100 nano, select moderate and click on apply. So if you click on apply, so it will be displayed here that whatever the analysis you have selected. Next, go to DC analysis, click on save DC operating point, then click on component parameter, then click on select component. So if you click on select component, the test circuit will be open and you need to click on the component which is connected to the input, namely the V pulse. So click on this and then double click on this DC, right? So that component is the component parameter for your test circuit. So minimize this, come back to this window, give the start time as 0 and stop time as 1.8 and click on apply again and click OK. So once you click apply, the DC analysis will also be displayed. Next thing is regarding the outputs. Go to outputs, to be plotted, click on select on design. So if you do this, you need to open the test circuit again. On the test circuit, click on the input line and the output line like this. Now come back to this window. So input and output are displayed here. Next, come to edit variables on the right side, right? Then click on copy from. So you can see WP. WP was the width of the PMOS which we had given it earlier. So select this, give the value as 2U. U means micro, okay, equivalent of micro, it is 2 micro. Then click on apply and OK. Once you click on apply, it will be shown here on the right side. Then you need to go to tools, select parametric analysis. In this parametric analysis, click on this add variable, a drop down menu will come, click on this WP. Range you are supposed to specify from 1U to 4U and total number of steps will be 4. You give that and click on this run icon, which is run selected sweeps icon, and wait for a while for that to process and give you the result. It will process for some time and it will give you the result. The waveform will be displayed of both transient analysis as well as DC analysis. So this side is your transient analysis on the left. Just click on this and right side there is an option to split it. Split all strips. If you click this, transient analysis will be split. So you can see that for every high there is a low on the output and for every low there is a high at the output. This is your transient analysis and this is your V in and this is your V out. So we had given the DC voltage as 1.8. So on the Y axis you can see the value from 0 to 1.8 and on the X axis you can see till 100 nanoseconds, which was the stop time which we gave. And on the right side there is a DC analysis and 4 different curves are there, right? So after this you are supposed to do the calculation. One is the delay calculation and one more is the intersect calculation, for which you are supposed to go to the tools and click on calculator, right? So this is the calculator part which you get. So special functions are there. So if you don't get that, you can click on this function panel and these things will be displayed. So first let me select the delay part. Click on delay, right? So for signal 1 you need the input value and signal 2 you need the output value from the transient response, right? So whatever the value is there, I'll just delete it, which I don't need it. I'll open the graph, right click on VIN, click on send to calculator, and I'll open the calculator, some value, I'll get it here. This value I have to paste it for signal 1. So this is the input value from the graph. Similarly, from the graph, I'll right click on Vout and I'll send to the calculator. So this is the Vout value from the graph. I have to paste it for signal 2. Threshold value, you give it as 0.9, which is half of 1.8 volts which we gave it earlier. So threshold value should be half of the DC value which we give. Edge number 1 and 2 has to be 1 itself. And there are two types of delays, which is called high to low and low to high. So first we need to will calculate rising to falling. So edge type 1 has to be rising and edge type 2 has to be falling. Next we will do the opposite. So first I'll click on apply here. Once I click on apply, you will get some equation like this. Don't worry about the equation. You just need to get the value. For that, there is an icon like this: evaluate the buffer and display the result. This icon you need to click. If you click on this, 4 different values will come. So this is TPHL values for 4 different values. Next, I'll minimize this and I'll change the edge type. Earlier it was rising. Now I'll make this as falling, and this falling I'll make this as rising. Then I'll click on apply. One more equation you'll get. So again, I'll click on this particular icon, that is evaluate the buffer and display the result. So once you do that, you will get the other set of values which you are supposed to note it down. And also you are supposed to note down the values from the graph also. So these are the 4 different delays. First one is TPHL1, this is TPLH1. Second one is TPHL2, TPLH2, TPHL3, TPLH3, TPHL4, TPLH4. So once you note down the values, you can close this window. Second thing is you are supposed to calculate the intersect after the delay. So come back to the functions panel, click on all. Now you click on the intersect. Okay, intersect is over here. So for signal 1 and signal 2, again you are supposed to give the values from the DC response of the graph. So I'll just remove these values. I'll go to the graph. So now you have the DC response. Right click on VIN, send to calculator. So whatever the value you get here, paste it for signal 1. Again go to calculator, right click on Vout, send to calculator. Then whatever the value you got from the graph, you paste it for signal 2 and click on apply and OK. So once you click on OK, you get a graph. So once you click on OK, click on this evaluate buffer and display the result. So you will get the 4 different intersect values. The first 2 is for the first intersect, second 2 are for the second one, third 2 are for the third one, and last 2 are for the fourth one. Note down these values also. So delay value and intersect values are the ones which you needed. So this completes the first experiment, and same procedure you are supposed to follow for rest of the experiments.